All right, in this video, we're going to go ahead and finish up our implicit differentiation notes, finding the derivatives of equations that aren't solved for y and can't be solved for y super easily. So in this example, this equation, which is called the equation for the cissoid of Diocles, by the way, very fancy, you know the Greeks and their math. We're going to find the derivative or just in general, the derivative, and then we're going to determine what the slope of the positively sloped tangent line is at x equals 1. And so if you'll notice at 1, right, it's not a function, so when I plug in 1, I get out two outcomes. So one of them is here, and then one of them is here. So basically, it will determine the slope of the positively sloped line at x equals 1, okay? Excuse me. All right, so first let's find dy dx. Every time, I just want to write it. What's the derivative of 2y squared? Well, that would be 4y. And then because I'm taking the derivative of y, I tack on a dy dx. And then in this next piece, we're doing product rule secretly, and it's up to you. I don't like to usually mess with the negative in my product rule. I like to just do x times y and then treat it as a subtraction symbol that I will then distribute to my product rule. But if you wanted to treat this as a negative x, you could do that as well. So for this piece, let's see, I'll have my x will be my f prime would be 1, and then my g would be y squared, and so then when I take the derivative of g, I get g prime, and I get 2y dy dx because I took the derivative of y, crisscross applesauce, so then I get minus 2xy dy dx plus y squared, right? So I just found the product rule, so that subtraction symbol stayed there. I will have to distribute it, but again, I don't like to really mess with it as a negative. And then the derivative of x cubed is 3x squared. All right, so now let's go ahead and distribute that negative. So I have 4y dy dx minus 2xy dy dx minus y squared equals 3, x squared. And so now all my dy dx's are on one side, but I got to move this y squared over to the other side first. Okay. And so then now on this side, I only have terms that have dy dx in them, so I can go ahead and pull that out as a GCF. So dy dx, and then I'll be left with 4y minus 2x y equals 3x squared plus y squared. And our last step would be to divide both sides by 4y minus 2xy. So my final answer for my derivative for this equation would be 3x squared plus y squared divided by 4y minus 2xy. There isn't a term that's common between all four of these, and then there is no number that goes into, well, there's no number here, but 2, 3, and 4. So I can't pull out anything, or I can't reduce this at all. Okay, so that's my derivative, and now we want to find the slope of the positively sloped tangent line. So it gives me my x value. How do I find the y value to plug in? Because you'll notice I have to plug in x's and y's to find my derivative. How do I figure out which y value to plug in if I only know my x value? Well, you could guess from the graph, or if you have your x value and we want to find your y value, you could also just plug it into your original equation. Right? If I have x, I can find y from just a regular equation. So my regular equation was 2y squared minus xy squared equals x cubed, and I'm plugging in x equals 1. So I get 2y squared minus 1y squared equals 1 cubed. And so there, 2y squared minus y squared would give me just a y squared, and I would get 1. And then you square root it. Your two y values that you get out, oops, that means y would equal plus or minus 1. But which one of these produces a positive slope? Well, my 1 value or my negative 1 value? 1. Okay, so then to have dy dx, I go ahead and just plug in 1 comma 1 for every variable in here. So I do 3 times 1 squared minus 1 squared all over 4 times 1 minus 2 times 1 times 1. That's a lot of ones. All right, so I get 3 minus 1 on top, which is 2. On the bottom, I get 4 minus 2, which is 2. So then I get 1 as my slope. All right, let's try. I think I got 2 more examples. All right, so in this example, I have, this is the one I started with, right? My x squared plus xy plus y squared equals 3, the equation of my ellipse. So I'm going to go ahead and find the derivative of that. So, actually, you know what I'm going to find? Equation of the tangent line. And so automatically, remember what I told you to write every time you see the words equation of the tangent line, y minus y1 equals m x minus x1. My x1 is 1, right, from my point. My y1 is also 1 from my point. And to find m, that means I'll have to find my derivative at 1 comma 1. So now I have to step over to the side and find my derivative. Let's do it. Okay. I don't think I'm going to have enough room up in here, length or width-wise, so I'll do it down here. So derivative of x squared is 2x. And then I have a nice product rule happening, x times y, right? So x, so f prime would be 1. Y is my g, so then 1 dy dx. Remember, every time you take the derivative of y, you tack that on. Crisscross applesauce. So I have plus x dy dx plus y, and then now I have to take the derivative of just a regular y squared. So I get 2y dy dx, and the derivative of 3 is 0. All right, I got to get everything with a dy dx on one side and everything without a dy dx on the other side. So I'm going to go ahead and subtract these because literally it's just less writing. So then I have x dy dx plus 2y dy dx equals negative 2x minus y. Go ahead and pull that dy dx out as a GCF, so dx dy, or dy dx plus, or times x plus 2y. Okay, and then to get dy dx by itself, you just have to divide both sides by x plus 2y. So our dy dx would be negative 2x minus y over x plus 2y. No, you can't cancel anything because you have addition and subtraction going on, and there isn't a 2 in every single term, so I just have to leave those alone. All right, so I found my derivative. To find my m, my slope of my tangent line, I go ahead and plug in 1 comma 1. So I would get, let's see, negative 2 times 1 minus 1 over 1 plus 2 times 1, which would give me negative 3 over 3. So my slope would be negative 1. And then for my final answer, I'm going to actually write out the equation of my tangent line because that's what it told me to do. So y minus 1 equals negative 1, times x minus 1. So at the point 1 comma 1, here's my tangent line. Oops. We could do better than this. I learned that we can do better than this. Here is my tangent line. And so this would be the equation of that tangent line. Cool, all right. All right, let's do our last example. All right, so this one, find the equation of the tangent line at the point negative 3 comma 3. So that one's not even technically on this graph, so we can't use the graph at all, but that's what it looks like. If this is your equation for it, so the derivative of 1/3 x cubed would just be x squared. And then we got a nice product rule happening here. So x 1 And then y squared is my g, so g prime would be 2y dy dx. Crisscross applesauce. So we would get 2xy dy dx plus y squared equals, on the right-hand side, I get negative 8y dy dx, because I took the derivative of something that had y in it. All right, and so then now let's move over, let's see. It's kind of up to you guys. I tend to put my dy dx's on the left-hand side, so let's scoot those guys over here. And then we'll add my 8y dx's to both sides. All right, so on the left-hand side, I'll have 2xy dy dx plus 8y dy dx equals negative x squared minus y squared. Go ahead and pull that dy dx out as a GCF. 2xy plus 8y. And then the last step is to get dy dx by itself. You divide both sides by 2xy plus 8y. So dy dx would be negative x squared minus y squared over 2xy plus 8y. Oh, I got ahead of myself again. Look, they want the equation of the tangent line again. My goodness. Y minus y1 equals mx minus x1. x1 is 3. No, negative 3. y1 is in fact 3, and then I just found my dy dx, so that will be helpful because I'll be calculating my derivative at the point negative 3 comma 3. All right, so let's plug it in. Negative 3. Ooh, watch those negatives here. Mostly telling myself that. Oops. All right, so we got negative 9 minus 9 more would give me negative 18. Then 2 times negative 9 would be negative 18 plus 24 would be 6. So my derivative would, or my slope would be negative 3. All right, so then last step, to write my equation of the tangent line, get y minus my y1 was 3 equals m, which is negative 3x plus 3, because it's x minus a negative 3. Make that plus prettier. I promise that all of your equation of the tangent lines don't always end up being always the same number. They just happen to be for these last two. But yeah, that's how you do it. So go ahead and practice and let me know if you guys have any questions.